Traversing an array involves systematically accessing each element in a sequential manner, commencing from the index position 0 and proceeding through the array until the last element is reached. This fundamental process allows for the examination, manipulation, or utilization of each individual element within the array. Firstly, we require an array, and subsequently, there are 5 steps to follow. In the initial step, we initialize the variable I with 0, representing the first position in the array, holding a value. Here we refer to index 0 as the lower bound. Moving on to step 2, we initiate a loop to access all the elements of the array. In this example, we use a while loop. However, other loop structures can be employed. Regardless of the loop used, the process remains the same. The loop continues until we reach the last index of the array, referred to as the upper bound. The third step involves performing operations on the accessed elements using the array name associated with the index as demonstrated by a in brackets I. In step 4, which falls under the while loop block, we increment the variable to access the next element in the array. Step 3 and step 4 are enclosed within the while loop. They are processed until all the element inside the loop has been visited. Once all element in the array has been accessed, the program terminates. Let's take a look at the animation that helps to grasp the array traversal algorithm. The array in focus has 5 elements, and as we discussed, the initial lower bound is set to 0 and the upper bound is equal to the length of the array. The key components of this program is the while loop, which drives the traversal process. Pay attention to the position of the pointer on the array and the value of the lower bound in the animation. After each pass of the loop, the lower bound changes, shifting the pointer to a new position. The C programming code presented below is an implementation of the algorithm we discussed earlier in this lecture. In this demonstration, we initialized an array of size 5 with specific elements. The array begins at the program start, setting the lower bound to 0, indicating the starting position for accessing array elements. It is important to note that the lower bound can be any value greater than or equal to 0 and less than the size of the array. To determine the upper bound, representing the total number of elements in the array, we divide the total memory occupied by the array by the memory occupied by each individual array elements. A while loop is then employed to traverse through the individual elements. The loop continues until the lower bound is less than the upper bound. Within the loop, two operations are performed, printing the value and incrementing the lower bound to point to the next element for access. Upon accessing all the elements, the program exits the loop and concludes with the termination of the program after printing the last printf statement.